Hello YouTube, we're going to give this another shot. The first couple of times I recorded the audio on this, it didn't take. So I've plugged in my wire. We'll see if maybe my old headset, maybe the batteries are going bad or something. I don't know. Hopefully this will fix the problem. So we are on to bag C with our TT-02R Rally build. It's the last bag of the kit, and then after that comes the body. So step 29 is checking up your RC equipment. So you want to make sure you've got your transmitter and you've got your battery, receiver, speed control, and servo. So if you don't have a transmitter, pretty much any transmitter will work. You only need a 2-channel. Nothing fancy is required. If you have something fancy, yay you. As far as the battery goes, most people nowadays are using LiPo battery, although the speed control that comes with most Tamiya kits is not LiPo compatible. So if you've got a TBLE02S or something similar laying around from Tamiya that you want to use, great. You'll want to go ahead and use a NIM battery with that. They're a little heavier, bit punchier at first, but they bleed off their voltage quickly as they get lower on energy. So they start out a little bit hotter than a battery, LiPo battery. The added weight, in addition to the very dramatic droop in power, um, tells me that for this type of application, you're better off using a LiPo battery. Get something good. Don't buy cheap. I tend to use the Duratrax Onyx batteries. Hard plastic case, so it's rugged. The ones I'm using are 2 to 3 years old, and they still have good ohm resistance. When I charge them, they don't get hot. They're not getting puffy. Fantastic batteries, in my opinion. So you'll need a speed control, right? Tamiya brand speed controls, none of them have proper LiPo cutoff, so I typically avoid them unless for 100% sure I'm never going to use a LiPo. And then, of course, you'll need a receiver. If you're looking for inexpensive transmitter-receiver combo, look to FlySky. Get them on Amazon, get them on eBay. You can pick one up for 20 or 30 bucks, including a receiver. Dirt cheap. They typically come no antenna, which is good for this application. So keep that in mind if you're buying something new. The Tactic stuff also from Tower Hobbies is decent for inexpensive stuff. You can also get a transmitter and a receiver combo, wireless receiver for like 50 bucks for the 300 series, or maybe 40 bucks for the 200 series. And then you'll need a servo. So the servos will have 23, 24, 25 spline. On the output shaft here, if you're going inexpensive, you can go with the Tactic. TSX 40, I think, is the one that's high speed. For an application like a rally car, speed is more important than torque. It's a very light car. You won't have any problems with even a basic servo like a Futaba 3003, but more speed is better. And then you'll want to make sure that whatever spline you happen to have, depending on brand, you match that up with your servo saver. Okay. So this is what I went with for electronics. I use the Savox 1257TG, stands for titanium gear. So this is ball raced servo, digital servo with metal gears. It has this aluminum orange band around the middle of the servo housing so that it helps dissipate heat. It's a bit overkill for this build, but that's what I went with because that's what I wanted to go with. For most of my basher builds and even a couple of my racers, I'm not the most amazing racer ever, so the LRP Spin Series ESCs are perfectly fine for me. They've got two. They've got the Pro and then the Super. The Pro will allow you to go lower in the turns. I would think that 13.5 in this chassis is about as hot of a motor as you want to go with. That's what I originally installed with this car. And honestly, I think it was too hot. So I've just recently, since the build and doing this video, clearly, I have gone down to a 21.5 rather than the 13.5 that I originally installed. So at any rate, the Super Spin is the I think a very, very solid choice. They're small, they have a cap built in so you don't have a cap bouncing around, they've got a power switch built in so you don't have to wonder where you're going to mount that. They've got a very long warranty. They're really pretty rugged. The only downside to the Spin series is that the wires are pre-soldered onto the board, and they are well, I'll get to that in a second, I think. And the receiver that I'm using is a Spectrum SRS 4210, which is a leftover from my son's Losi XXX SCT that he was racing with. So we upgraded his electronics. So I'm borrowing his electronics from that truck. So this is what I was talking about before. The wires are pre-soldered onto the ESC case underneath the housing. Not very easy to rewire longer wires. So this comes already pre-wired with connectors. You can see the Tamiya style bullet connectors are here, and comes with a Tamiya style Molex connector, I believe. It's been so long since I did this build, I don't remember if I had to put the Dean's connector on it or not. If it doesn't have Dean's, switch to Dean's. If you're using the old Molex style, switch to Dean's. I don't care what truck you're driving, switch to Dean's. Or Castle, or XT60, or something not Molex. They're not designed to handle the power of modern A batteries. They should have gone away 10, maybe even 20 years ago in the hobby. If they haven't melted on you yet, give it time, they will. So anyways, this is what the gear looks like out of the box. So like I said, I'm repurposing the transmitter and receiver from my son's old Losi XXX SCT. So this is the transmitter that came with. It's just a entry-level Spectrum DX2E transmitter, which is totally fine for this application. You can only bind one vehicle to the transmitter, so keep that in mind. I did switch out the steering wheel. The wheel that comes on this is very lightweight, cheap plastic, and it made the overall transmitter feel really cheap. So for about $15, I think, off of Amazon, I picked up this Integy here, which is, here's the part number. Integy makes a ton of different styles. They all look like sporty aluminum wheels with a disc brake here behind it. Pick whatever style you like. I went with this style here because it was on sale. I like the looks of it. Also, the red matched up quite nicely, I think, with the accents on the Spectrum. So it looks nearly factory. At any rate, recommend doing that if you've got a lower end transmitter and you want to make it feel a little bit nicer. So like I said, there's an Onyx battery that I've been using, and you want to center up your servo before you drop it into your chassis. So just connect everything up. Make sure your transmitter and your receiver are bound together, and then power the whole shebang up with your battery, turn on the ESC, and then this will center up the servo. Make sure that your trims on this transmitter, it's these two knobs here, are both in center, and then you know that your servo is centered up. Once you have it centered up, then you need to install the servo saver. So the servo horn that comes with the servos, you're not going to use any of those. You're going to use a servo saver. And the servo saver that comes with the kit is a standard one, which will probably work okay. I wanted something a little bit more robust. So I went with this, the high torque servo saver kit from Tamiya. It's part number 51000. Right here is the part number. I should have written it down. I'm sorry. It's quite a bit more robust than the standard all plastic servo saver that comes with the kit. So the way it works is you align your servo in this direction, and then you drop the first mount down onto the spline. Now this is the important part, to know how many teeth are on the spline so that you get the proper adapter. So Savox and Futaba and Tactic, they all use 25 tooth splines. Other brands use different. These are the little rubber grommets and protectors that come with the servo. So depending on the brand of servo you go with, they may look like this or look differently. But these are super important. Now in the instructions, Futaba says Tamiya says just to bolt the servo directly to the servo mounts, right? Screws, washers, all together, what have you. I don't recommend doing that. If you want to really extend the life of your servo so that you get good long life out of it, use the grommets. They're there for a reason. They act as a little rubber suspension for your servo. So the way that you can put these on the end of the servo and then try to jam these brass bushings down through the hole once it's all in the servo, but that's difficult. So the way I do it is I get my little rubber grommet like so, and note that on the Savox here, there's one little spot that has a raised rubber bit that keeps the grommet from twisting. Other ones might be completely circular and they go in differently, but this is how the Savox works. So look for this little rubber jobby and make sure that it goes to the outside. When you put that into the servo, go ahead and get your brass insert, and I like to slide it down on a hex driver shaft, because if you try to jam this just with your finger down through that rubber, the hole in the rubber grommet, the rubber grommet likes to mush up, and then the thing doesn't like to slide in. This works very, very slick. So you get your rubber grommets into your servo. The rubber edge here is to the outside middle to keep them from rotating. Insert the hex driver shaft into the hole, and then you can slide the metal bushing thingy down, and it will just insert just fine. When you get to the very end, you see here my hex driver is hitting the edge of the servo, so this is as far down as I could go, which is not a problem. I just take it off and then push it in with the edge of my hex driver shaft. So that's how I install it. You can see how the little rubber ridge here rests in this slot to keep it from rotating around. And that's what it looks like when it's all set up. So this is the rubber grommety thing by itself, and then rubber grommety thing with the metal insert. Now the metal insert's super important, because if you just tighten this down with a screw, the screw will eventually pull through this rubber part, and then you'll end up with a mess. By using this, it adds rigidity to the inside of this rubber grommet. The screw pushes down against this brass bushing, right, whatever this is, which then pushes up against the servo mount, so the rubber grommet acts as a floating suspension. And then this is what it looks like when it's all the 4 bits are installed. Now, I did all 4 corners on the servo to keep things flush and even. If you're using the plastic stock servo mounts, you'll use screws in all 4 of these positions, but I'm using the GPM upgrades, so I'm only going to end up using 2 of those holes. So with the stock servo saver, it's got a plastic ring that you clip off of the sprue. With this high torque one, it uses 3 metal springs that interlay each other, similar to like a leaf spring does. And you get a bunch of different screws. Right? These screws came with the servo for different kind of servo mounting applications. So you want to make sure you pick the proper screw to hold the servo saver onto your servo. So I recommend testing out the screws before you get any of this stuff on, to check to see if you've got the right pitch and the fine or the coarse type threads on the screw. So you got your screws sorted out. You go back to the servo with the first ring, the first brass ring. They're both the same size. Go ahead and put that on. This is what it looks like. It's a bit of a pain, but it's not too awful bad because it's the smallest diameter. The next one goes on. As you can see, it's a bit more difficult. I marred up the edge of my servo saver here a little bit, trying to get it snapped down, because as though they're the same diameter, you have to stretch it out, so then you get some spring tension going, and it makes it more difficult to slip down. With determination, you can do it. And then the black one goes on last, and this is what it looks like. So we basically got a leaf spring arrangement. The black one is the hardest one to get on because, one, I think the black one is a little bit more tension than the 2 gold ones, and it's going around the largest diameter, which makes it more difficult to stretch out and snap back down. Again, with patience and determination, you will get it. Then the cap goes on and the screw tightens down in. So because I'm using a metal gear that has a metal spline, I put a tiny little bit of thread lock on the spline itself before I put the servo cap down in and stuff, so that I didn't put the thread lock on the screw and drop it down in. If you do that, it can maybe brush up against some of the plastic or what have you. So that's how I do that. Thread lock is important. Metal screw going into metal shaft will vibrate loose. So now we have to attach up the servo, right? So we've got the steering, the bridge steering here, and you got your steering push arm here. This is how you build up your steering arm, and this is the length of it. Okay, and then this is using the 2 plastic servo mounts. So we have to crack out bag C now. Up to this point, we've just been using parts from the radio gear and from the upgrade kit. So now I have to crack out bag C. I also use this. It's the TT-02 aluminum steering bridge, which replaces the plastic one that the instructions call for. This is part number 54575. And this will match up nicely with the bell crank, the rest of the bell crank that's aluminum. So these washers are tiny and thin. Oh my God, they are so small. Be careful when you're setting them down on top of the steering arm here, because they will drop and fall and they'll easily get lost. So stack 2 up on top, and then put your bridge down on, and then this countersunk hex head screw goes down through. Again, you're screwing into an aluminum arm, so put a little bit of thread lock inside of here before you put the washers on and put the steering bridge on and put the screw down in. So I wanted to continue with the aluminum hop-up thread theme that I've got going on. So while I've got the kit comes with aluminum steering arms, right? Adjustable steering arms for the front. I wanted the push rod to be aluminum as well, so I went ahead and ordered up the 23mm by 3mm turnbuckle shaft. So the front turnbuckles that came with the kit are already fine. It's the same deal as what these are. I just needed to get an extra one so that my steering arm was also adjustable and aluminum. So it's part 54248. You'll end up with an extra one, which is not a bad deal. So you need to cut your ball caps just a little bit, right? So I basically cut the A off of the word Tamiya. So I used a pair of side cutters, and then I got pliers to straighten it out just a little bit so it wasn't quite so smushy, because when you cut it with the side cutters it will smush the ball end down just a bit. And then I used a fine-tooth file to smooth it up. Making sure that they're about this length. But like I said, if you're using these ball cups, just chop the A off and you're good to go. Now, like I do with all my tie rods and turnbuckles and all of that stuff, just tighten them all the way down, right to the end. Doesn't matter. Don't worry about how long it is. It's already pretty close, as you can see, but it's a little bit longer than 48 in actuality, but you just squish it all the way down, tighten it all the way in. So I mentioned earlier that I was using the GPM servo mount, right? So the part number for this is TT-02R, produced by GPM. There's a couple of different servo mounts that are out there. The kit calls for the plastic ones. There's a couple of things that I really like to keep as rigid as possible in my cars. The servo mount and the steering are two of those pieces. So I like this servo mount because I think it's an elegantly designed piece. It only uses 2 screws to mount to the servo. All right, so it makes it a little bit easier to adjust. So once you crack it out of the bag and everything, this is what you got. You've got your 2 mounts, 4 concave washers, 4 countersunk screws, and then 2 nylon locking nuts. So I went into my kit, my spare kit parts and stuff, and I found this knurled head screw. I think there's a special name for these. I call it knurled head because it's got these little knurly things here on the head of the screw. At any rate, you want them to be 3mm shaft by 10mm long. That's what you need. They need to be longer than what comes with the upgrade kit, because remember, we're using the rubber grommets and those little bushings, which necessitates a longer thread shaft than the 8mm that come with. So this is kind of how this works out. You don't use the countersunk screws that come with the kit, and you don't use the little concave washer jobbies. Instead, you just use this. That's why you want this style here, because you need to have a long head that you can have good contact with the sides of the servo mount, and you want to have a flat bottom so that it doesn't rock around the way that, say, a concave one would for a countersink. So I flipped it over. This is upside down clearly. As you can see, I'm only using the one screw, the top screw, right, because this is upside down, so this is the bottom, although I do still have the rubber grommet in here to keep the same width. I put a little bit of thread lock in the bottom, in those recessed holes, so that when you stick the servo into the chassis plate and you screw it up from the bottom with the countersunk screws, you don't have to worry about putting thread lock on the screw. It's already in the socket. So step 31 is to install the servo. You can see we've got the steering bridge, the steering arm, the servo saver, servo, and mounts. So you put that in and screw the countersunk screws in from underneath. And then, whoops, I forgot. I can't zoom in with my mouse wheel. It moves the slides. So then you want to adjust your steering arm here so that you get the 48 millimeters from end to end. You do it here once it's snapped in, okay? You do that so that you can get perfectly even on either side. If you try to do this without this being mounted on, you'll have one side that shows a lot more thread than the other, and that makes it uneven. So this is what it looks like when it's all set up, right? We've got the servo mounted in the chassis with the GPM servo mounts, the 10 millimeter screws going forward with the nylock washer holding it on the back side. You can see right here and right here the rubber grommet to keep this a little bit loose and wiggly so that it protects the gears just a little bit. We've got the high torque servo saver with the ball nut, with the ball facing the rear of the car with the nut on the back side. Again, a little bit of thread lock on this to keep it from vibrating loose. And then here's the ball head screw that came with the steering kit, right? Well, you notice that it's at a weird angle. I don't like that. So I need to fix that. And I'll show you how in just a second. You got to put the receiver in, but we're not going to put the receiver in just by itself. So a rally car, it's going to be running the dirt, it's going to be running the dust, in the mud, and the muck. Preferably not underwater. This servo receiver case here, this receiver case comes on, I think it's the B part sprue, right? So I bought all the blue part sprues. This one's for the TT-02B, the buggy version. So you'll need 4 of these screws. They're 12 millimeters by 2 millimeter shafts, so they're a little smaller compared to what we're using. We've got the bottom and the top half of the receiver case. And here is the part sprue. Its part number for the blue one is 47335. There's black and then there's also white, depending on what you choose, but we're going with blue. We use parts number 4 and 5. Here's the top and the bottom of the receiver case. So I get out my alcohol, and I get my ESC, and I get my receiver, and some double-sided tape. This is the big piece of double-sided tape that comes with the ESC, but you're going to need a little bit more than that. Get yourself a cotton ball and dampen it down. Clean the bottom, clean the inside bottom and the outside bottom on the lower half of the case. The alcohol, just enough to clean off any oils, will allow the tape to adhere very strongly. So this is that big piece of LRP double-sided tape. It's bigger than anything I've got, so I went ahead and used it for the bottom of the receiver case. So as you can see, it pretty much fits perfectly. Then I got another piece of 3M VR servo tape. It's a gel-based servo tape rather than the foam stuff like what Tamiya sells and other companies sell, or even the 3M foam double-sided sticky tape. Those don't hold strong enough. I prefer the gel-based stuff. It's kind of like a gooey base rather than a foam. So I cut a piece just small enough to fit in here, and then I centered this in the dead middle. Now, because I'm using this receiver that has an antenna, I have 2 choices. One, I could either just wrap the antenna around the receiver inside the receiver box, which is what I did, knowing that by having the receiver antenna inside the box, I'm reducing my effective range on my transmitter because we'll have interference from the other electronics in the car. We'll have interference from it being so close to the ground, right? So that will reduce my range and possibly introduce glitches. I haven't seen that problem when I've driven it thus far, but know that if you follow these instructions and you wrap the receiver wire or antenna receiver wire around the receiver itself inside the box, makes for a tidier install, but it also could reduce your transmitter strength. But you see it has these 2 notches designed for the wires to come out. So you could run the receiver antenna wire out, put the cap on, and then the cap has a spot for an antenna. So you could put an antenna in it if you'd like. This is what the instructions say to mount stuff, right? They say put the ESC in the belly of the bathtub chassis and then put the receiver on top of the servo. I think that's a terrible idea because the servo is next to the motor are the two biggest components that will create electrical interference. So why are you going to mount the receiver directly on top of the servo motor? Plus, that's going to reduce the amount of heat transference that the servo has. So I did this instead. First thing you got to do is you got to mount your motor though. The motor's already in, but if you're using a brushless motor, you have to plug the wire in because most motors, the wire goes in on the end bell, and there's not going to be any space for you to get in here. So plug the wire in first. Make sure you've got a nice wire that has some flex to it. Some of the wires that I've seen are really, really firm, and they won't bend much, and this thing's going to have to bend at nearly a 90-degree angle. Then you drop the receiver box down inside the chassis. Try to set it up so it's not touching anything. That it's not touching this edge wall here or the back side of the steering servo, certainly not the center of the chassis. Get it as far forward as you can without touching the back side of the servo. This will give you as much room as possible for the sensor lead wires. Okay. I went ahead and got myself a glitch buster capacitor because Sabach servos are known to be power hungry, and when you do quick turns left and right, even if your ESC has a built-in capacitor, as most of them will, that servo might ask for more voltage instantaneously than what the ESC is able to just dump real quickly, and that's where these glitch busters come in. You can pick these up for just a couple of bucks. It's certainly worth it. This is the one that I'm using because it happened to come free when I bought the servo. Personally, I find that the diameter on this capacitor is really big, but it's a freebie, so who am I going to complain, right? I'll show you where I put this in a moment, but know that this is much bigger than usual. I have since swapped out this 13.5 to a 21.5, like I said, and I did change the capacitor from this to an LRP brand one, or a Spectrum brand one, which the capacitor size is quite a bit more narrow. It's not nearly this diameter, it's like half this diameter. Because it's so small, it actually fit inside the receiver box. So you get your wires in, right? So the glitch buster plugs into the receiver, you get your steering servo, and you get your ESC all plugged into the receiver. Make sure they're the right channels. You've got a piece of ESC tape on the bottom of your ESC, right? Double-sided tape. That's not going to go here. Nothing is going to go here. We've got our wire tucked out of the way, and I zip-tied all these together to keep them nice and tidy. And then I put the cap on. Now, it's VHB. This is my preferred double-sided tape. It's a gel base, 3Ms of VHB. I highly recommend it. You can pick it up off of Amazon on a roll for dirt cheap. Don't spend the crazy money that they want for double-sided tape because it says RC on the box. So this is how this looks, right? So I've got the ESC going into the one side underneath that little notch that I showed you earlier. The speed controls going in the steering servo is going in the other side in the other notch. And then because this was so huge, it wouldn't fit inside the receiver box. So I had to use one of my tiny little files, the Tamiya files, and file out a notch on the back side for the receiver to come out. Now it just happens to be that this ginormous receiver diameter is such that with a little bit of foam tape, it's snugged in nicely up against the edge of the chassis and the motor. Not an optional install, not optimal at all. But it's the best that I could do with the size of this glitch buster. So once you get everything mounted in, the ESC mounts on top of the receiver case, the top lid of the receiver case. So that works out pretty well because it keeps it away from the two main heat sources, right? Our receiver is tucked away neatly inside of the box, and the ESC is sitting on top. And that allows the servo heat to escape, it allows the ESC heat to escape, and allows the motor heat to escape. So now we get back to my problem with the servo arm, or the steering arm. Right, so the steering arm is jacked up. See the massive angle that this thing is at? That means as you push it away, so as you turn right, the servo is going to have to push this farther right than when you come left. So what we end up with is a progressive steering favoring to the right. There's no real way to fix that, because you have to have the steering centered, right? So if you turn left, it's going to push this bell crank farther to the left than it does to the right, which then turns your steering to the right more than it does to the left. So it makes the car prefer to turn right, and it might even turn a wider turn circle going left because the wheels, maybe the servo can't pull that arm far enough back. So we need to fix this. We need to get this as close to 90 as possible. So this is how I did it. So from a previous video, I said that I was using some of these 8mm hard hex head ball connectors, right? It's part 53969. These are rugged as hell, and they've got 3mm more thread on them than the standard ones. This is important because what we're going to do is we're going to take one of these and we're going to get a couple of our 1mm spacers. So we've got 2mm of space here. That leaves us 6mm of space. And when we put that in, that's pushing this out an extra 2mm beyond what it was. Okay? So yay, the blues match, and yay, we've got nearly a perpendicular. Okay? It's the best that I can do with what material is available. I could put another spacer in here, like say a 0.5mm spacer or a 1mm spacer. Probably a 1 would be ideal, but then I wouldn't have enough thread left in my ball connector to give me a reliable connection into my steering bridge. So this is my recommended setup. And while it does still slightly favor turns to the right, it's so minor that I can't tell a difference. So at the end of step 32, this is what we've got. We have our battery, again, square case, hard case LiPo battery with a star adapter, which is a Dean's compatible. And then here's the Dean's connector that's on the LRP. So the fact that that's a Dean has me thinking that it probably comes with a Dean's connector already up on it. Also because it has a black heat shrink instead of a red, and I tend to use a red. At any rate, doesn't matter. They're compatible. As you can see, they plug in. We've got our motor installed, our glitch buster here, our receiver box with our receiver on the inside with all the wires tucked neatly inside of it. We've got the ESC on top with the VHB tape adhesion, and we have our steering servo with our as close to 90-degree angle steering arm as possible and our aluminum steering bridge. Step 33 talks about the wheels. Now, the kit doesn't come with wheels. It does come with rims, right? But they're dish rims. I'm pretty sure that's right. But this is clearly not good for rallying. So I went ahead and I got a set of rally blocks, right? So 2 packages, 50476 rally block tires. I bought 1 package of the hard inner sponges, 53156, and I got 4 of these Tamiya wheels, right? So 2 packages of the Tamiya wheels that work on the, these are the wheels for the Suzuki Sprint rally car, which is what I'm using. I was going to use the Subaru, and I had a whole different plan set up, but then my son saw it, and he is using that now. So to build your wheels, you want to get your rally blocks, and when they come out of the package, I would recommend getting some Simple Green and cleaning them up, because the Simple Green will help soften the tire up. It'll get any kind of weathering or whatever that has gotten on the rubber. So clean them up nice and good with some Simple Green. Once they're dried, use a hair dryer or something like that, dry them out, and then you put the inner sponge. So you'll have to peel the inner sponges apart from the sheet. It comes in a sheet of 4. So you peel them apart and you get a strip like this, and then they go. Make sure they're nice and flat and flush, and that when they meet, they're not overlapped. These have to meet flush face to face. And if they do, you're good to go. Because they're cut at an angle, they won't overlap or pinch or anything like that, as long as you have them in nice flush. Then you pop the tire in. Now on the inside ridge of this wheel, right, there's an inner ridge here where the bead sets between this outer rim edge and this inner rim edge. So what I do is I push the tire down past this inner ridge so I have nice easy access to that channel. And then I get out my alcohol and a cotton ball again, and I rub this all along that channel, right? Like this. I just put that cotton ball in there, wedge it in there, and get it all nice and clean. Now we've cleaned the tires with the Simple Green, and now we've cleaned the edge of the tire as well as the wheel with the alcohol. and that will help the glue adhere better. So I prefer the AKA glues. I've tried some other brands and stuff, and I find this one is the easiest to apply. So you get your AKA tire glue. It will come with a tiny little bit of glue tubing, but I find that that's not nearly enough, so I bought an extra container of that. So here's the premium tire glue, and here's the applicator tube, and these are the part numbers. In addition to that, I'd prefer to use some rubber bands. You don't think you can buy the rubber bands separately. But you can buy it with a pack of glue. So this is it, and just the glue I've used up in that. But anyways, that's the part number for a bottle of the glue, including 4 rubber bands. I prefer to have 8 rubber bands. So you want to cut off a piece of tubing 1/2 inch long, and then insert the tubing into the bottle so that 1/8 or maybe 1/4 at most of the tubing is showing. And then, well, I guess I'll have to show you here. And then we push the tire down, right? You push it with your thumb and insert this into the space, and then slowly work your thumb around, creating space and squeezing the glue at the same time all the way around. Then as you move on, you want to make sure that that tire snaps back into that valley or whatever you want to call it that we'd cleaned up earlier. Once you've got the glue in, put the rubber band around it. Do all 4, flip them over, do all 4, so then you have 2 rubber bands, 1 on each side. On short course tires or something bigger like a monster truck or a stadium truck, there's actually space between the rubber bands, but these tires are so narrow that the rubber bands actually overlap just a bit. But anyways, and then let this sit for an hour or 2 at least. Usually I wait for overnight, just to be on the safe side. But if you're in a rush, give yourself at least an hour before you pull the rubber bands off. We're nearly there. Step 34, putting on the wheels. So I basically do this all in one step. Because this is a rally car, the ball bearings you want to use are ideally rubber shielded. You can use the metal shielded ones that come with the kit, but you're going to be cleaning them out a lot. I can tell you that right now. So the ball bearing goes on. You want to make sure that it seats all the way inside the wheel hub. Put the pin in, and then you will have, oops, okay, this one, make sure. Put the pin in, and then the hex goes on, then the tire, and then the lock nut washer. That's how the instructions call for it. Both sides basically the same. But we're not going to use the plastic hubs that come with the kit for a couple of reasons. One, they're more looks than they are functional. 2, they're pretty floppy. When you put them on, even if you get the pin lined up in that, they're really loose and floppy. I don't like that how to play at all. 2, when you store the car, you shouldn't store it sitting on its tires, because over time, if you store it for a long time, it will, like maybe over winter, the weight of the car will cause flat spots in your tires. So you either want to mount them off. So if you're displaying your car, get it up off the ground so that the tires are hanging in air. Or if you're going to store it in a box, you want to take the tires off. Or if you want to change the tires because of the different treads that you have on different tire choices, maybe you're going to run more on-road that day and you put more of an on-road tire, whatever. When you take the tire off, the wheel hub will fall off, the pin will fall out. It's a cluster. So if you use this, the aluminum wheel clamps, right, 5, 3, 5, 6, 9, comes with 4. These are more expensive than what you can buy off of eBay. I tried buying the Chinese stuff off of eBay. It's a third the cost of the Tamiya stuff, and it's crap. It's not worth it. Just buy the Tamiya stuff. The way that this works is there's a tiny little screw that clamps down, and then this metal hex, right, this metal hex end is now clamped onto the pin. So the pin is on the inside here, and it goes this direction, right? Now it doesn't fall off. It just stays put, which is fantastic. There's no slop, there's no play, it's nice and tight. The cheap Chinese ones, the 6mm hex might not be 6 millimeters. The width, right, might not be right. The screw heads snap as you try to tighten them down. You see how the clamp here is completely touching, right? So it's fully clamped down. The cheap Chinese ones, they don't tighten all the way. They have a hole, which means they don't actually stay on. So trust me, as expensive as these are, they're worth it. So we put the front urethane bumper on. This is one that came with the kit, so it's got like a concave front to it to help reduce the weight, I guess. I don't know. It doesn't weigh anything, so I don't know why they'd want to reduce the weight, but at any rate, it's got a concave front. It's the one that come with the kit. You drop it down on. a couple of 10mm hex head screws, or you can use the JIS ones if you want, I suppose, but I use all metal hex head M3s. And make sure you're using the inside holes. There are 2 holes out here for the outside ones, but those are for body mounts for other type of cars, so use the inside ones. This is what it looks like, right? So we got our hex head screw holding it down. Here's a little clampy thing. The nice thing about this is, in addition to giving us a bit of a bumper, right, it also protects the shocks from front impact. Home stretch now, we've got the body mounts, rear body mounts mount in the back like so. The front body mounts go around. The front body mounts are shorter, so if you can't figure out which is which, right, 5 and 6, but at any rate, that's how they look. And this is what it looks like on. So what we've got now is a front bumper installed. We've got our clamping hex head hubs on. We've got our body mounts on, and all we basically have to do is plug the battery in and we're done. So this is what it looks like from this direction. All completely done with the wheels on, with the rims on, and here's the back side, other direction, so you can see what it looks like. These rally blocks will give you a little bit more ground clearance than the slicks or something like that does if you were going to run this chassis on ground. So know that in addition to flipping the arms over and getting yourself a little bit more suspension travel, running with rally blocks or some other brand rally wheels, it will give you a little bit more ground clearance. So that's the end of bag C. I see that my little red light on my boom is still on, so hopefully I still have sound. If so, I will go ahead and publish this up and put it online real quick. There will be one more video at least coming in this series where I document putting the Suzuki Swift SX4 body together. So keep an eye out for that. Thanks. If you like this, please leave a like. If you got any questions, go ahead and post, and I do my best to answer them as soon as I see them.